Hi everybody, in this nugget we're going to magically turn big things into little things. Specifically, we're going to learn to compress files with both Gzip and Bzip2. Now we're going to of course learn how to compress and uncompress things using both of those tools, but then we're also going to cover how to use those tools with the tar command, because tar can actually compress things on the fly using either one of these algorithms. So first of all, the difference between Gzip and Bzip2. This one is older. Gzip has been around for a lot longer. Bzip2 is a much newer compression algorithm. It takes more horsepower, more CPU power to use. However, it can compress things far greater than Gzip. They're both still very valid and do a great job of compressing, but if you have a big file that you absolutely need compressed as small as possible, you're going to want to use the Bzip2 algorithm and program to do that. It's more powerful and it does a better job of compressing data. Now, I'm not going to even give you a whiteboard slide on how to use these. We're going to go right to the command line because using Gzip and Bzip2 is just dead simple. Now here in our little sandbox folder, I'll type ls and you'll see I have a file called bigfile.doc, and that file is just over a megabyte in size. So it's like 1.1 megabytes for bigfile.doc. And now to compress it using the Gzip protocol or the Gzip algorithm, we type simply gzip, the name of the file, and press enter, and it will actually delete the original file and replace it with a compressed version of the file. So here, this is 1 megabyte. It's compressed it down to 57 kilobytes. So this isn't like half. This is like a, gosh, I don't even know, what is that? Half of a tenth of the size that it was before. So Gzip is a very powerful compression suite, and you saw how fast it did it. As quick as I hit enter, bam, it was compressed down to, a very, very small size. And now to get it back, you use the opposite command, which is gunzip. Looks like gunzip, but it's gunzip. Bigfile.doc.gz. Notice that it added the .gz at the end. That's kind of the way you know it's a Gzip compressed file. So do that, and it will do just the opposite. If we type ls-l, it will replace the .gz file with the original one. So it strips off that gz and it gives us back the original uncompressed or expanded file. That's 1.1 megabytes. And now using Bzip2 is exactly the same way. Bzip2, bigfile.doc, but when I hit enter, you'll see it takes it a little bit longer. Now, fast computers are fast, so it didn't take a lot longer, but it took, probably about 4 or 5 times longer for it to compress that file than it did with Gzip. And that's because, like I said, it uses more horsepower, but as we're going to see in a second, it makes it far smaller. Instead of 57 kilobytes, it's down to 14 kilobytes. That's much, much smaller and a far cry from the 1.1 megabytes that it was before. So this BZ2 is the extension that it adds. That's how you know that it's Bzip2 compressed. And just like with the other one, we can say bunzip2, bigfile.doc.bz2, and it instantly uncompresses it, and it gives us back our original file, getting rid of that .bz2 file, and we have our original 1.1 megabyte file left. Now this is a text file. All files don't compress as well as text does. Like if you have an MP3 file, you can't get it like to 1/100th of the file size by using Bzip2. So it depends on what type of file you're compressing. However, Bzip2 is a very, very efficient compression program. Now you're probably thinking, couldn't I just like compress this folder? Well, no, you can only compress files. That's where if you wanted to compress all of the files inside these folders with all these folders, you would combine a tool like tar and you would compress the outputted tar file into like a tar.gz file. So let's look at how we can do that. We don't even have to use Gzip or Bzip2 in order to take advantage of their compression algorithms. Tar has those algorithms built right in. If you're not familiar with using tar, I urge you to go back and watch that nugget because tar is kind of a complicated beast. So I'm going under the assumption that you're familiar with creating tar archives or tape archives using the tar program. In order to utilize the Gzip and the Bzip2 algorithms to make your tar files smaller, what you do is you add an extra flag in the argument string here. So we say something to create a compressed tar file, we would say tar minus z for gzip, and then cvf, just like we would normally for creating a tar file. Normally we would just say cvf, and that would create a file.tar out of the directory that you tell it you want to create that file out of. If you add this z argument in there, it'll actually create a gzipped tar file to save space and make it far more portable. Now, to decompress or to untar a gzipped tarball, these are starting to sound like silly words I'm saying, but if you to do that, you would again add the z argument, and you would say tar minus zxv f, the name of the tar file, and it normally has a file extension like file.tar.gz, or sometimes you'll just see file.tgz. That's just a shorter way of saying that it is a tar file that has been gzip compressed. So either of these is correct. You can either say file.tar.gz or file.tgz. Both are a way of saying that it's a tar file that is gzipped. Now, to use bzip2, again, that even higher level of compression, this one doesn't make a whole lot of sense, I guess, because B was already used. You actually have to use a J flag. I know that's ridiculous, but J is the flag that you use if you want to use bzip2. And so just like with gzip, up there you would say tar minus jcvf, and then the name of the file, and then what it is you want to put in that bzip2'd tar file. And then to decompress it, the same thing, tar minus jxvf, and the name of the file. Now, just like up here with tar.gz, sometimes instead of tar.bz2, you'll see something like file.tbz, and that is a way of saying that it's a tar file that has been bzip2 compressed. So file.tbz is another way of saying tar.bz2. I know it gets a little bit confusing, but generally, I mean, if you're strictly a Unix person, it's okay to have multiple file extensions, and saying something like file.tar.bz2, that is far clearer and easier to tell what you're dealing with. We'll actually make some tar files on the fly that are compressed, and that'll do it for understanding how to use compression in Linux. Back here on our command line, I'm actually going to get rid of that big file because we don't need that anymore. Let's clear the screen, type ls-l, and here we have a folder that has 3 folders inside of it. So I'm going to create a tar.gz file that it will be a tarball of all these folders and files. Let's do ls-l star. You can see there's stuff inside these folders, right? The documents folder has files inside of it. The logs folder has a file. The music folder has MP3 files inside of it. So all of these files are going to be created as a compressed tar file. If we type tar minus z for gzip compression, cvf, and I'm going to call it file.tar.gz, and I'm going to say star, all of the folders in here. I'm going to press enter. It gives a listing of the directories and folders and files that it's adding. Type ls-l, and now you'll see that we have file.tar.gz, and it's a single file that is 8 kilobytes long that contains all of the documents in all of these folders. Now, we can tell that it's actually done its job by removing the existing folders. So all we have left is this file.tar.gz, and if we extract it using z, again for gzip compression, this time x for extract, vf, and the file name, it will extract those back. So if we do ls-l star, you'll see we have our folders back, and all the files are inside of those folders. So we were able to get all of those things back, and it was a very tiny file, just over 8K. Even though if you add these up, like this mysong.mp3 was 121 kilobytes in size, and it was compressed all the way down to 8 kilobytes. So let's see what we can do with bzip2 compression. So let's do an ls-l. We'll get rid of that file.tar.gz. It's interesting to note that like gzip andgunzip would delete the file once they expanded it. Tar does not work that way. So if we want to get rid of that file, we have to get rid of the file.tar.gz. So now tar minus j for bzip2, which is totally non-intuitive, I know, cvf file.tar.bz2 star Press enter, it's going to compress all the things. And if we do ls-l, now we'll see instead of 8K using Bzip2 compression, we're all the way down to 5.5 kilobytes for all of that stuff. Now I'll really quickly prove that it's worked. You can see that we have just the file.tar.bz2, and we can expand that by using tar-jxvf file.tar.bz2, and we'll see, boom, we have all of our files back. All of our folders back, and all the files are inside there. So that's how you can use tar and the two different compression algorithms at once to not only archive folders full of files, but also compress them so that they can easily be transported. It's a really slick way to use compression while using tar at the same time. So you're doing both at once. If you're a Windows person, the zip program, like .zip extension, zip and unzip, that actually does both archiving and compression all in one. And now in Linux, you can do the same thing, choosing between Gzip or Bzip2 compression. Compressing files with Linux is super simple, and then when you add the ability to use tar and Gzip or Bzip2 together using simply the tar command, it gets that much easier. So whether you want the Gzip or the Bzip2 super fast or super high compression that takes a little bit more time and a little bit more horsepower, they're both available for you to use on the Linux command line. I hope that this has been informative for you, and I'd like to thank you for viewing.